This is an introduction to right triangle trigonometry and solving triangles. The first thing to remember is this idea called Sohcahtoa, and Sohcahtoa is just a mnemonic, and SOH stands for sine equals opposite over hypotenuse. The CAH is cosine equals adjacent over hypotenuse, and TOA, tangent, equals opposite over adjacent. And sin, cos, and tan, that's what you'd see on your calculator. Different calculators work different ways, so you may have to figure out how to work your own. And so here we have our right triangle with sides A, B, and C. Here's our right angle. This is the angle alpha. This is the angle theta. And so the side opposite alpha is B. The side adjacent to alpha is A.
Excuse the interruption, teachers. Will you be sure to...
The hypotenuse is always C. The side opposite theta is A. The side adjacent to theta is B. We don't use trigonometry right now with the right angle. So getting started, we have side. So we're given the three side lengths, 8, 15, 17. And if you want to find sine of theta, it is Sohcahtoa, so opposite over hypotenuse. So the answer would be 15 over 17. Cosine of theta, CAH, adjacent over hypotenuse, so 8 over 17. Tangent of theta, opposite over adjacent, so that's 15 over 8, which you could get by doing sine divided by cosine. Sine of alpha is opposite over hypotenuse, so that's 8 over 17. Cosine of alpha, CAH, adjacent over hypotenuse, 15 over 17. And finally, tan of alpha, opposite over adjacent, 8 over 15. Now, notice that the tangents of these are just reciprocals for theta and alpha. And this is, of course, that the opposite for one side is the adjacent for the other. And that's also why the sine of theta is the same as cosine of alpha, and the sine of alpha is the same as the cosine of theta. This is if we're just given two sides. So the first thing you have to do is use the Pythagorean theorem to find the third side. So a squared plus 2 squared is equal to 9 squared. A squared is going to be 81 minus 4, which will be 77. And so therefore this side is the square root of 77. So now, sine of theta, opposite over hypotenuse, rad 77 over 9. Cosine of theta, adjacent over hypotenuse, 2/9. Tan theta, opposite over adjacent, rad 77 over 2. Sine alpha, opposite over hypotenuse, 2/9. Cosine of alpha, adjacent over hypotenuse, rad 77 over 9. Tan alpha, opposite over adjacent, 2 over rad 77, which you can rationalize the denominator, and you get 2 radical 77 over 77. So now, a little algebraic interlude before we use the calculators. And this is just because when we're solving triangles, we'll have certain equations that we'll need to solve. So first of all, if we're trying to solve this equation for x, ax equals b, we divide both sides by a. These cancel. We get x is b over a. If we have b is equal to x over a, multiply both sides by a. These cancel. X is a times b. This one's a little trickier, very useful though. A is equal to b over x. We can multiply both sides by x. So we have ax is equal to b, and then we can divide both sides by a so that x is b over a. But what I really want you to notice is that basically we just end up switching these guys, a and x. And finally, if a is equal to sine x, to get x all by itself, this is when we're looking for an angle, we have to take the inverse sine of a. And on a lot of calculators, this is the second button and then sine. And this works for all the trig functions. So now this is if we're given, in addition to the right angle, a side and an angle. So the way we set this up is if we want to get a, we say compared to this angle, what side is this, what side is this? So compared to this angle, this is an adjacent, this is a hypotenuse. So adjacent over hypotenuse is cosine, so we say cosine of 20 degrees equals a over 12. You multiply both sides by 20, so a is equal to 12 cosine 20, which comes out to about 11.27. At this point, if you wanted to, you could use the Pythagorean theorem, but let's use trig again. To get b, compared to this angle, it is the opposite. So we have opposite hypotenuse, so that could be then sine. So we say sine of 20 degrees is b over 12. multiply both sides by 12 and cancel, and you get b is 12 sine 20, which comes out to about 4.1. And then finally, to get theta, the easiest thing to do, of course, is do 180 minus 90 minus 20, and we'll get 70 degrees. So once you get a little more information, there's a variety of ways to get these numbers using different trig functions. Another example, we have 30-degree angle. This is 6. Compared to this angle, x is an adjacent, 6 is a hypotenuse. So adjacent over hypotenuse is cosine. So cosine of 30 degrees equals x over 6. So multiply by 6, and you get x is equal to 6 cosine 30 degrees, which is going to come out to 3. And then to get y, y is an opposite. 6 is a hypotenuse, so opposite over hypotenuse is sine. Sine of 30 degrees is y over 6, multiplied by 6. 6 sine 30 comes out to exactly 3 radical 3. I'm not sure what that is as an approximation, but the thing to notice is that this is really a 30, 60, 90 triangle, so you could have gotten this information without using trigonometry. Okay, for this example, now we're given a leg rather than the hypotenuse. Well, first of all, to get alpha, we can subtract from 180. So 180 minus 90 minus 25, we get 65 degrees for alpha. Now, as far as trying to get A and C, to try to get A, 4 is an opposite, A is an adjacent, so we do tan of 25 is opposite over adjacent. Now, the algebraic interlude, I mentioned how you can swap these two, so we end up having that A is 4 over tan 25, which comes out to about 8.58. And to get C, again, we could use the Pythagorean theorem at this point, but continuing with trig, 4 is an opposite, C is a hypotenuse, so opposite over hypotenuse is sine. Sine of 25 is 4 over C. Again, you can swap these. So C is 4 over sine 25, which comes out to about 9.46. And again, we can use the Pythagorean theorem sort of to check our work. So in all these cases, we've had the angle. Now we're going to go as if we didn't have the angle to begin with. We're going to have to try to find it. So we have 9 and 3 as our two sides. 9 is the hypotenuse. We want to get x. Well, one thing we can do to get x immediately, besides getting alpha and theta, is use the Pythagorean theorem. X squared plus 3 squared is 9 squared. And so we solve that, and we get x comes out to 6 radical 2. And there it is. Now to get alpha, sine of alpha is opposite over hypotenuse. So sine alpha is 3 over 9, which reduces to 1/3. Now if you want to get the angle, you're not given the angle, you want to get the angle, you've got to use an inverse trig function. So alpha is now the inverse sine of 1/3, which comes out to about 19.5 degrees. Easiest way at this point to get theta, subtract from 180 and get 70.5, but just going ahead with some trig, we can do cosine of theta is adjacent over hypotenuse. So adjacent over hypotenuse is 3 over 9, so again 1/3. So to get the angle, since we don't have it, we take the inverse cosine. So alpha is the inverse cosine of 1/3, and there's your 70.5. One more example. We have our sides 5 and 12, our side x, our angle. This is a rho, and there's theta. So first of all, to get x, 5 squared plus 12 squared is x squared. It's going to come out to 13. It's a 5, 12, 13 right triangle. To get rho, then since this is, we'll say this is now 13, we can use any trig function we want because we've got all three sides. But to get rho, I have here cosine. So that's adjacent over hypotenuse, so 5 over 13. And so to get rho, you take the inverse cosine of both sides, which comes out to about 67.38 degrees. Theta you can subtract from 180 to get 90 in this. To get theta, here's another way to do it. Tan theta, opposite over adjacent, Sohcahtoa, T-O-A. So 5 over 12, excuse me, 12 over, it should be 5 over 12. So then we take the inverse tangent of 5 over 12. And we end up with 22.62 degrees.